Okay, this is a video to help you with the lenses quiz. And by now I'm hoping that you've already watched the refraction videos. You've already passed wave behavior, so this shouldn't be all new to you. This is about specifically converging and diverging lenses. And I drew a diverging lens first and a converging lens second, just because it's, in my opinion, it's easier to talk about a diverging lens first. So what does a diverging lens do? It diverges, or it spreads apart light rays. So if you had a bunch of light rays coming in parallel to this axis here, it's called the principal axis, but I don't care if you know that term. If you have a bunch of parallel flat rays coming in and they hit this lens, what this lens does is it takes them and it refracts them apart. So these rays that came in wind up getting spread out. So these rays that get spread out, if I was standing over here and if I was looking at something that was over here, oh, I shouldn't probably draw another person there, huh? I don't want to confuse you. If I was looking at something that was over here, like a flower in a flower pot or something, that means that since these top rays came through the lens and went up, and these bottom rays came through the lens and went down, that means that no matter what, this type of lens, the image is going to be right side up. And it's also going to be smaller. Why? It has to be smaller because this amount of light from here to here, this top to bottom, goes into this lens. And when it comes out, it gets spread out over this much area. So the light that gets to your eye comes from a smaller area. So the light that reaches you comes from a smaller area. That makes the object look smaller. Now down here I drew a convex lens, and that's a converging lens. Why do we call it that? We call it that because if you have a bunch of horizontal parallel light rays coming in, this lens refracts the light the other way. It brings those light rays together, and those light rays cross over at this point. It's called a focal point. So if you follow a light ray that was on the bottom here, let me color it in red, I guess. If you follow a light ray that's on the bottom here, it gets refracted on its way in and on its way out, and it goes through this focal point and it goes that way. Whereas up here, let's say we had a blue light ray coming in, it gets refracted downward and downward, and it goes this way. So if you're looking at an object that's over here somewhere, let me draw another flower in a flower pot here. If you're looking, oh, this is horrible, but I'm sticking with it. This is pretty bad. If you're looking at this flower pot, then these light rays that left the bottom of the flower pot are now up here, and these light rays that left the top of the flower, they are now down here. So if this object is at a certain distance, it can be upside down. And if you put the flower pot right here at this focal point, see this dot right here, that focal point, then these light rays never cross anywhere, and you get no image. So that's another thing that can happen. And then lastly, if you put the object right here between this focal point and the lens, then your image is actually, and this is kind of bizarre sounding for now, but your object can actually appear back here somewhere, and it can be bigger. So this type of lens can make an object look upside down. It can make no image. It could be right side up. And it could be bigger or smaller. So it does, I guess I should write bigger or smaller. So just because this just popped into my head, have you as a kid ever used a magnifying glass to fry ants? What you're doing is you're bringing in all those light rays from the sun and you're converging them onto one point. So there's basically an image of the sun where you're frying the ant. Anyway, so those are in general what these two lenses can do, converging and diverging. And I think I'm going to stop the video here. I'm going to clean this up, and then I'm going to shoot the next one and show you how to draw images a little bit better.